Hey everybody, so we're going to continue working on some problems to help you with your study guide, and then you'll have the opportunity to go and work on the Unit 8 test once we're done kind of going through the study guide. If you feel like you want to go take a look at the test, sorry, the cat's trying to help. If you feel that you want to go look at the test, you do have multiple opportunities to take it, and it'll be open for quite some time. So if you want to go take it just to see what it looks like, feel free. And I'm going to take the highest score of all of your attempts. So anyway, here we go. Just a warning, it's like 12:30 in the morning, and this is like the cat's prime operating time. Sorry, you guys. Okay. So the first problem, we're just looking at logarithm rules, simplifying, expanding, solving logarithmic equations using the logarithm rules. So I see a lot going on in this problem right here. I see some multiplication out front of the logarithm, which tells me that that becomes an exponent. I see addition and subtraction, which means multiplication and division of the argument. So I'm going to handle each rule in its own individual step. So I'm going to deal with these numbers out front first. And any number that's out front becomes an exponent on the argument. So the number or variable here. So I'm going to rewrite that as log base 5 of x to the fourth power plus log base 5 of y to the second power. And then there was nothing out here on this third term, so log base 5 of xy. Okay, so now I'm going to deal with the addition and subtraction. Because they all are base 5, I can use that addition and subtraction to combine and simplify. So addition means we multiply the arguments. So we're going to multiply x to the fourth and y squared. We can't actually multiply them, so we're just going to make them into a multiplication problem. And then that still leaves log base 5 of xy. So this subtraction, if addition means multiplication, subtraction means division. So I can rewrite this once again as log base 5 of x to the fourth y squared divided by xy. And that simplifies down to log base 5. I have an x on the bottom, so that will change this 4 to a 3. And then I have a y down here, that'll change that y squared to just y. So then that's our answer. Okay. So over here I have a similar situation. I have a number out front, but I have an exponent in here as well. And then I have a number out here. So same thing, this becomes, the front number becomes an exponent on whatever is in the argument. So this becomes 4 natural log of x to the, natural log of x to the fourth power minus the natural log of b squared to the second power, and then the natural log of x to the third power. So my exponent rules tell me that I multiply when there's one exponent inside the parenthesis and one exponent outside. So I'll rewrite that as the natural log of x to the fourth power minus the natural log of b to the fourth power plus the natural log of x to the third power. All right, so they're all natural logs, so they all have the same base. So what I can do here, I'm going to take my addition. I'm going to do this a little out of order. I'm going to take these two things and combine them. So the natural log of x to the fourth power times x to the third power and that's minus the natural log of b to the fourth power. These two things will combine into x to the seventh power. And this subtraction brings b to the fourth power down here on the bottom in the denominator. Now, since x and b are two different bases, I can't combine any further, so that's my answer. Okay, so here we were condensing, making these smaller. Down here we're going to make our exponential or our logarithmic expressions longer. We're going to expand them. So I'm looking for everything that's happening here. I see several exponents, I see multiplication, and I see division. So I'm going to start with the multiplication and division. So I have log base 7 of 2 to the third power. It's being multiplied by x to the negative third power, so that'll be plus log base 7 of x to the negative 3 power. And then it's being divided by y to the negative 4, so that's going to be minus log base 7 of y to the negative 4 power. And now I can start dealing with all of those exponents. So I have a 3 here, so that's going to come out here to the front. I have a negative 3 here, so that's going to come out here to the front. And I have a negative 4 here, so that's going to come out there to the front. So I now have 3 log base 7 of 2 plus negative 3 log base 7 of x, and then minus negative 4 log base 7 of y. Well, now I've got these double signs here, so I'm going to clean those up a little bit. So I have 3 log base 7 of 2. This becomes minus 3 log base 7 of x, and this minus negative 4 actually becomes plus 4 log base 7 of y. All right, now this one over here, I have the natural log of all of these things, so I at least don't have to worry about writing a base. So we'll start out the same way. The natural log, I'm going to split up all my multiplication and division first. So the natural log of negative 2 plus the natural log of e to the third power minus the natural log of x to the fourth power. So there's no exponent here, so that's okay. This is going to come out here to the front, and this 4 is going to come out here to the front. So the first thing I can do is rewrite that as the natural log of negative 2 plus 3 natural log of e minus 4 natural log of x. But there's one more simplification that we can do. The natural log of e, those two things eliminate each other. So what I'm left with is the natural log of negative 2, and I'm going to bring this minus 4 natural log of x over first so that we just have plus our constant 3 at the end. And so this is our answer. This is the expanded version of this expression right here. All right, so now I want to get into solving. And so we have some exponential expressions, and then I have a logarithmic or a couple of logarithmic expressions and equations for you to solve also. So I'm going to start here by subtracting a 1 from each side of this equation. That gives me 5 to the x minus 1 equals 1. And now I kind of have to use my knowledge of the exponent rules. I could use a logarithm to solve this, but in the end, I still have to know that 5 to the 0 power would equal 1, which means that x minus 1 has to equal 0. So if I add a 1, that means that x equals 1. Now over here, what I have is log base 8 of 3x minus 6 equals log base 8 of x plus 2. So there's a logarithm rule, if you remember, that says if your log base is the same, it does not really matter anymore, because since, for example, these are both log base 8, the arguments have to be equal to each other. So 3x minus 6 equals x plus 2. I'm going to use my preferred method for solving, but you feel free to use whatever method you like. If I divide both sides by 2, I get x equals 4. All right. So now let's look at this one here. 8 times 5 to the x power equals 200. So the first thing we need to do is divide both sides by 8. And that gives me 5 to the x power equals 25. Again, I could use a logarithm to solve this, but I know that 5 to the second power equals 25. And I'm kind of put that in parentheses because that's not really part of solving the equation, but it's something that I know. So that means that x has to equal 2. Now over here, I'm going to use a logarithm to solve this one. You could solve it the same way that we just did this one here, but we're going to use a logarithm to solve this one. So I have 4 being raised to an expression that has an exponent in it. So I'm going to reverse that by doing log base 4 of 4 to the 2x minus 1 power equals log base 4 of 64. So my log base 4 and my 4 eliminate each other, and that leaves me with 2x minus 1 equals log base 4 of 64 means how many times do we multiply 4 by itself to get 64? Now you could plug this in your calculator, but I know that 4 times 4 is 16, and then one more 4 makes it 64, so this would be 3. I'll put off to the side here because 4 times 4 times 4 equals 64. So now I'm going to solve this equation. I'm going to add a 1 to both sides. I get 2x equals 4. And then if I divide by 2, I get x equals 2. All right, last 2. Okay, so all we're doing here is simplifying. Hopefully we can simplify way down to a single number. So this one actually is sort of like what we just did here to solve, where we had a base of 4, so we did log base 4 to get rid of that. I have a base of 2, so I'm going to do, or I'm sorry, so the log and the 2 eliminate each other, and so what's left here is 32. All right, so over here with 4 log to the log base 2 of 16 power, there's actually a couple of ways that you can do this. So I'm going to show you the first way. The first way would be to say, okay, well, I can turn 4 into an exponent with a base of 2, and so that would be 2 to the second power to the log base 2 of 16. And then I know from my exponent rules that I would multiply those. And so then this would come out here and be the exponent on 16. So this would actually become log base 2 of 16 to the second power, which is 256. Oh, and this 2 should be large. I don't know why I just did that. And now I've got a base of 2 and log base 2, so those cancel out. And so what I'm left with is 256. But there is another way to do that. So this is method number 2. So if I start with 4 to the log base 2 of 16, I want to evaluate my exponent first. So in other words, if 2 is my base, how many times do I need to multiply 2 to give me 16? Well, 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So log base 2 of 16 is 4. So the other way we could write this is 4 to the 4th power. And if we put that in our calculator, we get 256. So either method will take you to the same answer. All right, so please remember that I'll be online from 11 to 12 each day. I'll post the link to join the discussion. So come prepared with any questions that you might have, and make sure that you are completing your classwork assignments and that you're writing down your work. That will help you tremendously when the time comes to do your Unit 8 test. Okay, I hope to see you soon.